I think recording has already started. Okay, so let me just begin this. All right, so remote method invocation in Java language. It requires naturally background of Java language, which all of you have it. Uh, and most of the videos have already been uploaded. You can go through them if required in YouTube. And today we will complete the last maybe concept, remote method invocation, RMI. And what it is, let us just go through this. Just for your understanding, you can refer to tutorials point also, no problem. Essentially, the very name suggests that you are invoking. That means you are calling. You are calling a method that is existing remotely on a different machine, right? That means basically all of you know that Java programs are going to be executed in a platform called Java Virtual Machine, JVM, not on the real processor, right? So it is going to be executed on a JVM. The Java classes are going to be loaded into JVM, and then they will be executed. Now, what we are saying is you can have two JVM, two Java virtual machines, one running on the client machine, another running on the server machine. So what is going to happen is that one of the class is going to be running on the server machine actually. The class whose method is to be called is going to be running on the server machine. But that can be called from a client machine. Right? So basically it is useful for distributed applications, building them and all that. It is a mechanism that allows an object residing in one system to access or invoke an object running on another JVM. It is a simple mechanism. To do all that, naturally you require some support classes, and they are all available in a package called java.rmi. That is a package that contains many classes, and we will be using those classes to build RMI client server applications. What is the general architecture here? Naturally, if you see, take a look into this diagram. You have a server program, you have a client program. So how are they going to communicate with each other? Naturally, it requires the network support in the background. So client is going to be connected to the stub. Stub is is a kind of a Java entity that contains the methods that are to be called on the server. So you will have an idea about which methods are to be invoked on the server from the client. And those things are available in the stub actually. Why we are calling it as a stub? Because it doesn't contain the actual code. It only contains the signature of the method and what is the object that is likely to contain that and all that. So the actual code will be running on the server machine. There you will have a skeleton. These two will talk to one another. The stub will talk to skeleton. Skeleton will talk to stub. But the real object will be residing in the server code, in fact. So the actual call is received by the skeleton. And then it's going to actually any parameters are there for the method. They are to be properly marshaled. They are to be properly sent over the network. That what it is packaging all the parameters into one kind of entity is called as marshalling. We call it parameter marshalling. So they are going to be unmarshaled in the skeleton. They are marshaled at the start. They are unmarshaled at the skeleton. So that The skeleton will really again call the server method. Server, like within the server, whatever the actual method is there, that is going to be called. You get some result, that result will come to skeleton. The same result will be again communicated back to the stub. Anyhow, so client, stub, and then RRL, remote reference layer, it is called as. Right? So there is a connection between those two we are thinking of. And then the transport layer talk to another transport layer. Right? So all these things. We have been doing this like on our own by using TCP based programming and all that. So for example, we used to have echo server or converting a string into uppercase. Server can do that. Client can request. So we have been doing that, but there is a lot of steps that are involved there. So you have to first create a socket and then bind the socket and then like listen for the connections and then accept it, and after that perform a lot of read write. So there is a lot of like steps that are involved in creating client server applications in a normal mode. Whereas here in RMI, you are going to have this RMI support that's going to take care of all those socket creations, other things, and all that particular thing. So, strictly speaking, anyhow, whatever I told, they are all related to C language, system calls, and all that. But in Java, you have other things, server socket and socket class is there. They are all going to be. Anyhow, so this is about the different layers that exist. The transport layer actually ultimately, like what it is, sends the actual data over the transport layer, all the parameters, the actual call to the method, all those things. Stub is a representation or a proxy of the remote object at the client. Right? It is a proxy. It is not the real one. So it is a representation of the remote object as the client. It resides in the client system. It acts as a gateway for the client program. Skeleton, the exact opposite, which is going to exist on the server. This is the object which resides on the server side. Stub communicates with this skeleton to pass request to the remote object. So there is communication between stub and skeleton. RRL is the layer which manages the references made by the client to the remote object. So how are you going to develop the applications here and all that? There are a number of steps that are involved. Marshalling and unmarshalling, just now we said, there is something called, whenever you want to pass the parameters are to be bundled. Whenever a client invokes a method that accepts parameters, the parameters are bundled into a message before being sent over the network. These parameters may be of primitive type or objects even. If they are of the primitive type, the parameters are put together and a header is attached to it. In case the parameters are objects, they are to be serialized and then sent over the network. And this process is called as marshalling. And this is going to be done by the stub actually. The stub will take care of all this. At the other side, the skeleton will take care of, again, extracting all the parameters back, right? So the packet parameters are unbundled and then the required method is invoked. This process is known as unmarshalling. Okay, so all these steps are one side of it. The other thing is, like how does the client know, like what exactly is the object that is running on the server, right? And how are you going to get the corresponding object to the client and all that? So there is actually a mechanism called a registry. So server will register or server will bind the methods that are to be invoked by the client actually. So there is a kind of a program that will be running continuously, a service that is going to be run continuously, which we call it as RMI registry, remote method invocation registry. There you will actually register all the methods that are going to be available for the client to invoke them. So you have to register there, like this is the method name, and in the sense like a kind of a name will be attached to that, and then the corresponding object will be passed to that particular entity. So you can see here RMI registry is a namespace on all server objects are placed. Each time the server creates an object, it registers this object with the RMI registry using bind or rebind methods. Bind means for the first time. So rebind is if it is already there, if you again try to bind it, you will get an error because you are trying to bind with a name. Bind with a name or with some object actually. If you again try to bind with the same name because it is already existing, it will actually throw an exception kind of thing. So whereas if you use the rebind, it doesn't have an exception because rebind means it knows that if it is already there, you again like replace that. That's what you mean by. So rebind is a more appropriate one many a times, so that if you again rerun it, it doesn't throw any exceptions kind of thing. We'll look into that. Binding and rebinding. You are binding a name to an object whose method is to be invoked, basically. Then this is going to happen at the server side, remember. This binding is going to happen at the server side. Whereas the client, now it would like to know what are the methods that are there on the registry. So you have to something like search or you have to look up for that particular thing. And that process is called as lookup. To invoke a remote object, the client needs a reference of that object. At that time, the client fetches the object from the registry using its bind name, using something called lookup method. So, RMI registry is there. All of you need to understand that. Registry maintains all the methods whose, in other words, all the objects whose methods are to be invoked as a part of the registry there, as a part of that. You can see here the diagram that explains what it is doing and all that. Whenever server runs that, immediately as you can see, binds the objects in the registry using rebind method. Using rebind method or bind also you can specify, no matter. Whereas the client, whenever it starts, it fetches the object from the registry using the lookup. Because there may be many different servers, remember that. So all the servers and all the clients that use RMI will make use of the same RMI registry. It is just like any other server actually. RMI registry server, you can say. So it is going to run on one common code so that all the servers and clients can talk to that. Now, client and server need not what it is, know their port numbers, their IP address, all such kind of thing is not required. So what is required now is only the RMI registry, common RMI registry. So once the client fetches the corresponding object, then it can invoke the method. So client invokes the methods using the fetched object. And whenever it invokes this, it will actually talk to the stub. Stub in turn will send, will marshal all the data and send over the network to the skeleton on the server. Skeleton unmarshals or extracts the parameters and then make a call onto the real method on the server. And that in turn returns a result, and the result is to be communicated back to the client. So the business of a client and server talking to the RMI registry happens only once actually, only at the time of starting. Whenever the server begins, it is going to register all its methods that are available remote for RMI purpose. They will all be registered in RMI registry. Once it is registered, then the server can be busy trying to wait for any call to happen from the client anywhere. Similarly, client also only one-time job of fetching the object from the RMI registry by using lookup. Once the object is available with the client, then the client can call the method through that object any number of times without actually the RMI registry. So in that sense, like whatever the object that server has created is indirectly made available by placing that object into the RMI registry. A reference of that object, that's what you mean by. Right, so this is all the language of the Java we are actually talking about. Right, so this is what exactly happens in RMI. So when it comes to writing programs and all that, then we need to know what are the classes that are available in RMI for our purpose and all that. So that is what we are actually going to study now. In fact, before this RMI, there used to be, right? You are now talking about the Java actually. Do you have something similar to that in C language? Right? There is, and that is called the remote procedure call, RPC. So we normally call them as procedures, functions in the C language, right? So that's why they are calling it as remote procedure call in the case of C language. So the same thing is made available in Java also once the Java language has come into picture. That's all what it is, essentially. Now let us actually go through the steps that are involved in developing the what you call client-server RMI applications. So to write an RMI Java application, you would have to follow the steps given below. They're very simple. So first you have to define the remote interface. Interface means all of you know. We will only write down the signatures of the methods. We do not implement, but we will write down the what are the methods that you want to make them available for RMI purpose. Only those things. So define the remote interface. For that there is a procedure actually. So there is already an existing interface is there in the RMI package, java.rmi package. Right? We'll look into that. So first define the remote interface. Wonderful. You have only defined the signatures of the methods. But then at some stage you implement them. So the second step is that. Develop the implementation of the remote object. First step is only you develop the methods, signatures of the methods. Second step is you are now implementing all those methods. Then the third step is, because now you know how to create an object of that remote object. So then like you have to develop a server program now. So that within the server program, you will create the corresponding object, remote object. What are you going to do in the server program? You create the remote object in the server program. And then bind the remote object in the RMI registry. You have to make it available, right? So you must bind the remote object in the RMI registry. And after binding, it is available naturally as a part of it. That's what the server program is. And then you have to develop the client program. Client program, what it is going to do. So there must be something called, so you have to first, the client program must communicate with RMI registry for the method, remote method. So, and try to get the corresponding object on RMI registry by using the lookup method, naturally. So client program will try to get the remote object from RMI registry, right? So once you get the object, you now naturally put it into some object variable or whatever. Once the object is there, it is very simple. You are going to simply call the corresponding method as if it is there within your JVM, even though it is there somewhere else. Right? So these are the four things that you have to develop. And after that, simply compile all the Java programs and then run them. So simple, right? So one is define the remote interface and then complete the corresponding remote class implementation of that. And then server program and client program. Very simple. Now we can see as an example, how are you going to define the remote interface? The remote interface provides the description of all the methods of a particular remote object. The client communicates with this remote interface. To create a remote interface, what is to be done? So create an interface that extends a predefined interface called remote interface. Already, Java.RMI has got an interface called remote. And that interface only you have to extend, remember that, which belongs to the package, whatever. So because Java.RMI is giving the support system, and you are trying to make use of it. Declare all the business methods that can be invoked by the client in this interface. Since there is a chance of network issues during remote call, an exception can occur. And the exceptions that are going to be thrown here are remote exceptions. Right? So following is an example of a remote interface. So here, what are you doing? It's a very simple example, only one-way kind of communication. So client will send a message, right? So we'll actually invoke a kind of a method to which you pass a string parameter, which you might pass a string as a parameter, even not even that in this case. So no parameter even, basically. You can take a look at this code. So what is happening here? So you can take a look at this. Import java.rmi.remote. Import java.rmi.remote exception. So if you feel like why to write 2 lines, you can always say import java.rmi.start. Instead of 2 lines, you'll have a single line there. But then how are you going to creating the interface? Public interface and then interface name. Extends remote. This name can be anything, but this name must be the same. So public interface, hello interface name, extends remote. And then inside this, have all the methods that you want RMI to be using. So in this case, he is basically using the print message, print MSG, void, it returns nothing, but throws remote exception. Because it might fail anytime. So then you are saying throws remote exception. That's all. It is such a small program. First step is over. Second step now is you have to implement this print MSG. This particular method you have to implement. It is only, signature only is given here. Now in the developing the implementation class, so you are going to implement that. It will be straightforward, as you can see. So public class, and then any class name you can give. Here he is giving implementation example like that. You can say hello implementation, something like that. It doesn't matter. Implements what? Your interface that you have just now defined. That's what you are actually saying here. Whatever name that you have given to the interface, the same interface name you will be using here. So that's all. Like so, class implements interface, and then within this, write down the entire thing. Public void print message. It's not taking any parameters here. Curly brace begin. System.out.println. This is an example RMI program. So he is developing a very small example whereby no parameters, no end result is getting communicated. So almost marshalling, unmarshalling is very limited. Not like you are not sending anything. Actually, to make things a little bit more involved, we can have a parameter here. We'll see that, like by developing, we will add all those fields later on. But it is as simple as this. So the second step is over. So you are implementing the class by implementing the interface as a part of the class definition. After this, now these 2 steps are straightforward, very simple actually, because they are independent. Whereas now developing server and client, they require a registry actually, RMI registry. You have to bind your object, remote object, to be available for the client to look for that particular service or whatever. So there are some more additional classes and all that, which we'll have to look into that. That is, those steps are a little bit more involved. So developing the server program. So what do you do in the server program? So RMI server program should implement the remote interface or extend the implementation class. Here we should create a remote object and bind it to the RMI registry. Essentially, we have only created the class actually so far. Using that particular class, you have to create an object, and that creation of the object happens in the server. And that the created remote object must be registered in the RMI registry. Create a client class from where you want to invoke the remote object. Create a remote object by instantiating the implementation class. Export the remote object using the export object method. So now you are exporting the remote object by using this. Of the class name, unicast remote object. There is a class called unicast remote object. In this, there is a method called export object, which belongs to the package called java.rmi.server. Java.rmi.server. So get the RMI registry. You must get a registry object actually. You must get the registry object and then what it is, bind them and all that particular thing. Using the get registry of the locate registry class, which belongs to the package java.rmi.registry. Bind the remote object created to the registry using the bind. All that. You can take a look into the steps here. This is a server program now we are talking about. Third step. So import all the essential things. Now we can see import java.rmi.registry. RMI registry is there. For that, in order to do that, we have these things. Java.rmi.registry. Capital registry. Similarly, there is another class called locate registry. Java.rmi.registry.locate registry. And then java.rmi.remote exception as usual. And within the server you have java.rmi.server.cast_remote object. Those are the classes that are to be imported. Now we can take a look into the actual program. Public class server program. This name can be anything, whatever name that you want to give, you can give it. Right now here, to make things easier, because this is a server program, you are just simply saying server. Public class server extends what? Extends your class. The class that implemented the RMI methods. That's what you will have to understand. So it is extending the IMPL example or hello example, whatever name that we actually give it, we'll have to see. Now define the constructor method. Nothing. Public server, do nothing. And after that, write down the main method. Public static void main of string ops, curly brace begins. And because there is a might be thrown and all that, keep all of them inside the try block. So you say try, curly brace begins. What is the first step in the server? You must create the object, right? The remote object must be created. How do you create the remote object? Very simple. By using the new operator. So actual class name is IMPL example. This is the name of the class that we have created. So that's why the name of that variable name is equal to new IMPL example. So we have now created a remote object that is available in the variable called OBJ. And this must be somehow registered into the RMI registry. Right? We'll have to do that. But before registering that, creating the stub as a part of that, so that is going to be registered there and all that particular thing, right? So you can see here. So you are creating a stub out of this particular object by using something called unicast remote object dot unicast remote object dot export object of, right, and that particular OBJ, comma 0. These are the standardized set of instructions that you have to follow it, because somebody else have developed all those RMI and all that. The higher level understanding is you have created the actual object, remote object, and then you are creating a stub out of that particular thing by using unicast remote object dot export. And because it's going to now return, what is this going to return? The hello interface kind of thing. That's why you are actually typecasting. You are typecasting this particular thing into hello interface. So you are actually saying hello interface, the way starting interface, and then this name can be anything. This stub name can be anything. It doesn't matter. So we have now created a stub here, and that stub will be registered in what I call RMI registry. But before registering into the RMI registry, you must have a corresponding object, right? That object you are actually getting, because Java means everything is with respect to classes and objects. So now you are about to engage with the RMI registry. So for that you are creating the registry object. So registry is equal to locate registry dot get registry. Locate registry dot get registry. Locate registry dot get registry returns a registry object. Remember that. And this registry object can be used for binding purposes. This registry object can be used for binding purposes. Now we can see registry dot bind off. This name can be anything. Remember, this is only a string. The next one is cannot be anything. It should be whatever that you have exported, right? The same thing you have to give it. So here you are saying bind off. You are binding this particular stub with this particular name, so that in the client side you will search for the same binding, same name. Server is binding this object with this particular name. Client will look for this stub with this particular name, with the same name. So registry dot bind of hello comma stub. There ends the matter. Once the server binds the RMI method, RMI object, whatever, then it is ready now. So whenever the server receives any call like that, it is going to attend to that. You don't have any of those things. So those things are actually implemented in the RMI package, Java.RMI package. So once that is there, Java server is ready, as you can see. It's printing that. And as a part of running any of these statements, if any exception happens, you are coming to this kind of server exception. There ends the matter. This is the server system. There are only basically 3 steps that are involved. The first step, straight away, you have to take the what is the out of whatever class that you are actually implementing. So that part is straightforward. Now this object now somehow is to be put to the registry, and that is a 3-step process. First, you have to export into your interface style, so that you are going to get the interface stub equivalent. So that's what hello stub is equal to unicast remote object dot export object of whatever object that you have created, comma 0. And then this is to be put into the registry. So before putting it into the registry, you must create the registry object. So registry equal to locate registry dot get registry. Once there, you already know you have to bind it. So registry dot bind off whatever name. So there ends the matter. This is server related thing. Now you have to do the client part. Same thing, client part also. Once you understand the server, client part is simple now, because you know how to handle the registry and all that. So instead of going for bind, you will go for lookup. That's the only change. You can see here in this particular thing. So Java import java.rmi.registry.get import java.rmi.registry.get. Because server related stuff you don't require here. So whereas in the case of server, you have server related stuff import business. You can see here java.rmi.server.custom order. This is not required, right? In the case of the client, it only talks to the RMI registry. And RMI not remote exception, but that also may be required definitely in the client also. Exceptions is required, right? So definitely that part is missing here, I think. So class exception and all that is actually talking about. But you also import java.rmi.remote exception, even though he is not using that. So public class name, in this case client, and then specify whatever the constructor method and all that, no issue. That can be anything. Public static void main, all that. Now client. In this case, as we know, client what it has to do. It must talk to the RMI registry and get the RMI object. Remote object it must get from the RMI registry. So that's why here he is saying registry could locate registry dot get registry of null here. This is the only change that you will have to look into. In the server side, no parameter, whereas here you will have to specify a null value so that it's going to get a registry object as a part of the client here. So once you have the registry object, now you have to invoke the lookup table. How do you invoke the lookup table? Simple. Registry.lookup method. And then whatever name with which you have bind there, same name you have to use. So the moment you use the hello lookup, then whatever the stub object there that is already formed, that object you are going to get. So that's why you are again typecasting to hello and hello followed by stub. So that means now this is the actual remote object that you are getting from registry. And now you can use this remote object to invoke the method straight away. So you can say stub.print message. You are calling the print message on this particular object. So your server is putting the remote object on the registry. Client is getting that particular remote object from the registry. And once you get that, you can invoke the method straight away. So the point is that this print method code is not available within this particular JVM. It is available elsewhere on a different Java virtual machine. And whenever any of these try methods, try statements fails, it comes to the cache. That's all. Like this is the actual program. Right? So if you have any questions or if you find it difficulty, we can look at that. Is it okay now? All of you are getting my voice, following that?
Yes, sir.
Yes, sir.
Okay. So this is what exactly it is. And now I have taken all of them into this particular Jimmy IDE. This is the IDE that we will be using. So what I am doing is here, hello is there, client is there, hello implementation is there, server also you require it, somehow server is missing. We can get the server also. Okay. Now we can let's take a look into this. I have actually changed the name so that it becomes easy for me and all that. Instead of some IMPL something we said, we are using hello IMPL, hello implementation. So we can take a look into hello.java. Right? So import java.rmi.remote, import java.rmi.remote extension. Public interface, hello extends remote. All. This is the interface. Right? So corresponding class hello implementation. Hello IMPL. Is the actual name of the class that I'm using. Right. So we'll be using this particular name. So that's why inside the code also should be public class hello implementation, hello IMPL implements hello. write down whatever it is. System.out.print and all. This is like RMI program. Right? So these are okay. After that, what? Server Java. Server code is this particular thing. So import java.rmi.registry. Similarly, registry.registry. Remote exception is there. And then RMI server.unicast remote object. So public server extends IMPL example. This is not correct. It should be hello IMPL. Right? It should be now your own kind of thing. So it should be hello IMPL. Like this. Public server, it is a constructor method. There no code is there. Static void main, all that. And then hello IMPL is okay now. Object equal to new hello IMPL. We are creating the remote object basically by using that particular class name. And after that, you have to export using unicast remote object dot export object of obj comma j. And then get the registry object. Use that registry object to find the stub that is created there as a part of that. Right? So the same thing we have just repeated, whatever is given in this case. Now as a part of this, now client. Import all that client program. And then registry, locate registry, dot get registry of null. Hello stub equal to all that. Look after that. Stub dot print message. Same thing. Now, like we have saved everything, server dot some more things, like you say. All four programs or files are saved. Now, how do you actually run these things? How do you compile? How do you run? That we have to learn. Now, let us go into what you call this particular, which is a terminal, where all the four programs are there. All the four programs are there as a part of it. You can see only Java programs are there. Now we have to compile them. If you want to compile, you can just simply say Java C followed by, because you have to compile all of them. So you can straight away give in fact star on top. Java C followed by star dot Java. Either you can give Java C followed by client.java. Again, Java C followed by hello IMPL.java. Like that also you can do it. Or you can compile all of them at once by saying star.java. So I will just simply give it now. You can see. One step activity of compiling all of them. So it has created all the necessary classes, as you can see. Client.class is there, hello.class is there, hello IMPL.class is there, server.class. But how are you going to run the code now? Which program is to be executed and all that. As you all of you know now, you have to first run the registry actually. RMI registry must be executed so that server can register or find the remote object on the registry. It is a service, remember that. So that's why you have to run that registry service actually first. And for that, there is a command called RMI registry. There is a command called RMI registry. Just like you have Java C, Java and all that, this RMI registry also is a command that is available or that you are going to get when you install the Java Java package, basically. Right? Whenever you install Java, and with that, all these things will come. Even RMI registry also is part of that particular bin folder. Whatever. So just simply invoke this RMI registry. It's going to run on a particular port number and all that, remember. And server within the, whenever you are talking about unicast remote object, dot export object of So that is going to take care of talking to this RMI registry server. Simply run this. So it is running here. And actually, right now we are in the shell. RMI registry is currently running. Once this is running, now we have to run the server program, right? Server program, go into that. You can see where we are. So this is the place where we are. Now you have to run the server program. How do you run the server program? By just simply saying Java followed by server. Java followed by server. Now we can just simply say do it. Here server is ready. Server is ready. Now you have to run the client program. Now you have to run the client program. Here also we are in the same place. You can see this is a present working directory, RPC folder, or whatever folder where you want to keep you can. But remember, when you are saying JavaScript followed by star.java, you should be such that only your RM related Java programs are there. If you have a folder where many other Java programs are there, then it's going to unnecessarily compile all the other Java files also. That's why it is better to create one folder specifically and start in RMI activity. So that only your RMI Java programs only will be there. Then JavaScript followed by star.java is going to be useful. Right? Otherwise, if you are in another folder where many other Java files are there, then star.java will unnecessarily waste a lot of time. Okay, so that is one part of it. Right now, the registry is running and server is running. So client can get the service. So how are you going to do that? By just simply saying Java followed by client. Java followed by client. And once you run the Java followed by client, what is the result that you are expecting? This client fellow invokes the print message. It so happened here, actually, like we are running everything on the same machine, no doubt, but on different JVMs. Client is running its own JVM, server is running its own JVM. Remember. But you can also run those things on different machine altogether. So that's also possible in fact. So the moment you run this client will invoke the print MSG. And print MSG will go to the server. Server will print on that particular screen, right? So whatever. So when you say Java followed by client, it is executed. Now if you look into the server side, see here in the server, this is an example RMI program. It is printing that. It is printing that particular. So you can invoke the same thing once again. Let us see. So it's again invoking. We can come to this server side here. So this is an example RMI program. Like that. It can go on any number of. So now probably like client is already over. It has already come out of that. Server is still running. You want to get out of that by just pressing Ctrl C. Right? I have stopped that particular thing. Now client is terminated, server is terminated, but the registry is still going on. Registry service is still going on. Remember that. Now if you want to start the server once again, like this. See, you are getting all these exceptions, all these errors, because that particular name, the name like hello, whatever, binding is already there. Because your client server, your registry server is already running. It has registered one remote, whatever it is, object there as a part of that. So server is again trying to bind with the same name. So you will get all these exceptions. Instead of this, if you just simply say, as a part of a server, instead of bind, if you use a rebind, for example, use rebind. Means if it is already there, you replace with it. If it is not there, you bind it. So that kind of stuff. So now I am actually saving it and go back to Yes. And compile the server thing. Compile the server thing. But RMI registry is still going on. We are not disturbing that. So let us try to compile once again the server program. Once again, compile that. Now the compiled server code has got the rebind instead of the bind actually. So now if you run the server, you can see you are going to get server ready. Server is ready. Now you can again come back to this particular client and run this particular. Now you can come back to this and see. This is an example RMI program. So now it is possible for you to shut down the server and again restart any number of times without actually worrying, getting that exception mechanism, all that particular entity. Right? So here you can run this and all that. But this is a very primitive version what we have actually developed. Now let us actually make some changes so that a string can be passed as an argument to that, and that string is going to come. That string is going to be printed here. Probably the string can be read from the client also. So you can read like something and then send it over there. Right? So such kind of thing. Now we can slowly do that. Right? Let us make some small changes so that those things can be added here. So first thing is interface. Print message. So it is more appropriate to pass a string to this. So you say string here. String followed by yes. So this is a small change that you are making. So that it's not going to print always the same message. Instead, it's going to print the message that you are actually passing on. Now the implementation part, allow implementation. Here also the signature must be the same, right? String followed by. And what are you going to do? Here you are going to print that particular yes. Maybe you can say even received, right? Received. Instead of println, I can use printf, right? In which case you can use received so and so. Received so and so message, percentage, yes. Message. Some client. New line. Comma? Yes. Like this. So if you want to put this into double quotes, into quotes and all that, you can put that. How do you put all that? You can put a reverse slash followed by double quote, and again another reverse slash followed by double quote. So that whatever message that you are sending is going to be printed within the double quotes. So this is a small change that you are making, right? So print MSG. Now the server, what is to be done? Is there anything to be done in the server? Nothing, because it is the same allow implementation, nothing as such. So everything is ready now. You are rebinding, whatever, all that. Client side, definitely some changes are required. As you can see, you are getting that particular thing, and then stop dot. So this is not the way that you are going to call it, right? So here we have to now have some kind of what? You want to read something also. So if you want to read something, so you'll have to put import followed by something like you can say Java dot. We will use scanner class util dot scanner. Java dot util dot scanner. Scanner class we will use to read a line basically. So we must have actually define the scanner object. Scanner let's see equal to new scanner of system.in, right? So you have created a scanner object. Then what? To look up for that and all that. But before that, before calling the method, we must read. Okay. So we'll say system dot out dot print. And then enter a message. All that. Okay. So one this thing, like whatever that you want to read, right? You must declare, right? So for that you require some string object. String followed by some line, yeah. Line, yeah. And now enter a message. So L is equal to, right? L equal to scanner object. SC dot next what? Next line. That method is there. And whatever that you are actually reading, you will be passing on that particular thing. Now stop dot print message up, yeah. Print message up, yeah. Or we could have actually used the command line argument itself. That job would have been much more simpler in fact. Right? See, you can use all your intelligence depending upon like what it is and all that. So right now we are trying to read it anyhow. Or command line argument also we can. So it all depends upon what you want. So now stop dot print message up here. So that this is going to be printed, not always the same thing. So client also is done now. Now you have to compile all of them. We can go back to this particular thing. And then what? Here. You see, these are the things. To be safe side now, again, we can compile all of them. Star dot job. That. Now, registry is still going on. We can, like, it can still continue, no problem. Like, because we can rebind. Right? We are able to rebind it. So, without having any issue. Or if you want, you can also terminate this and again restart. No issue. Anyhow, so that is going on. Now we have to run this server program. Java followed by server. Server is ready. Client here, Java followed by client. Now enter a message. This is what it is, right? RMI with one side communication. With one side communication. We don't know what happened, whether it is received or not and all that, but we can test it here. You can see here received RMI with one side communication, message from client. Right, so server still continuing. Client, you want to run this again any number of times, you can always do that. So here, line 5, something like that. So then again, you are going to see that particular. Now you can understand now, like how to get the result back so that that result can be printed on the client itself. Right, that is the next step. That is the next step that we can actually do that. So that, right? So all of you are slowly following, I hope. So now we can add to this this particular thing. Instead of calling this as print message, same thing now, uppercase kind of thing or whatever, right? Imagine as if all that. So instead of print message, probably what will we call it? So it's going to convert this, right? So print message, it's not going to print it, but it returns. So essentially what we are expecting, you need not have a single method in fact. You can have any number of methods, remember. So this can be there. Let us retain this as it is, right? And then we can have one more method. And that method, what it does is string followed by, it converts basically. Uppercase, case upper, whatever you call it, right? Upper, just simply upper, let us call it. Upper followed by, and then it takes as a parameter string yes. Then it throws again same. These problems are still going to be there for this also. Remote followed by exception. Like this. Okay. So this is there. Like this, you can add any number of methods to the interface. But now you have to implement that, right? So as a part of this hello implementation, string upper, we have to implement. String upper, we have to implement. Like this. Okay. Now it is going to be string. It is returning string. And instead of this, upper. Like this. Now we have to return the conversion, uppercase conversion of that, basically. So you can say return yes dot to uppercase. We have to find out whether this method is correct or not. Let me just verify. Let me just verify that one. You can see here there is a method called to uppercase. To uppercase also see in capital letter. This may be in JavaScript or Java. So that we'll have to be careful. Java string to uppercase. To uppercase method. So what? Let us assume, right, everything should be all right. So you are basically returning yes dot to uppercase. So naturally it returns what? Returns this result back to the client, which is running on a different JVM. Running on a different JVM. So this part also is over. Server, do you have to do anything? Nothing. Because it is the same object. You don't have to worry about what methods are there inside and all that. The client will take care of which method to be invoked and all that. So server has only the knowledge of creating the object. And once you create the object has got all the features. Whatever the things are there. Only thing is you have to again recompile. If you make any changes to the hello interface or hello implementation part, you have to recompile the server, definitely. Otherwise, you will have the server running with the old kind of what it is, the hello implementation and all that. Only compilation part is required. Server code, nothing is required here. Whereas the client side, because we want to invoke even the like what you call the uppercase corresponding thing, we want to do that. So that particular thing can be L comma result or we call it. Now you are calling the stub dot this thing. Result or is equal to stub dot upper. Upper of what? L. Whatever L that we have this. And then print the corresponding output. System dot out dot println followed by R. Simply print followed by. That's all. So you are actually adding all the functionality and simply add this. So we have like saved all that. Now it's a matter of compiling all the things. So we say again Java C followed by star.java. So everything is compiled. Server is there. Here it is client. This registry is still going on. So you need to just simply run the server. Java followed by server. Server is ready. Now client, just simply Java followed by client. Enter a message. Right? So RMI is easy to learn. You can see here, the client has received the uppercase this thing, and you are printing that RMI is easy to learn. Same thing should have been communicated back to this. And here also you can see that. So like this, you can very easily implement RMI corresponding remote method invocation. It's a matter of just simply learning few existing classes like unicast object there, all those related stuff. Only one time job. The other thing is now how to extend this, what kind of business logic you want to implement as a part of RMIs and all that is up to you. It's going to be very simple, except that you must have reasonably good Java language foundation, and then remaining things you can always add on and then make RMI a lot more powerful as a part of that. Any questions at this point of time?
No, sir.
Okay, so if everything is all right, then probably 9:51. So we have come to that particular stage. So that is about RMI. And then I think as far as the syllabus is concerned, to my knowledge, we have touched each and every part of it. So I don't know how much are you actually going through that particular thing. Uh, Only 12 students are there today, and the examination schedule is already announced. I think all of you have started registering for the first semester exams. So there's some last date and all that. Foundations of Computer Science, right? Already that course is covered. So still one mid exam, second mid exam is pending, and the final semester exam is pending. And lab exams are also there. So now you may have to start preparing seriously. Uh, and as far as this Java course is concerned, not Java, network programming, we'll have to now, like, as I said, the topics are completed. If you have any interest and any topics that you want to be covered, once again, or some doubts are there, whatever, we can have the classes, right? Next Thursday, once again, we can have it at 8:30 or whatever. Uh, and then, if you have the things, we will have it. Otherwise, I'm planning actually. I'm planning to conduct some kind of quiz activity or whatever in the class. I will ask randomly the questions to the students, and then you'll have to answer them kind of it. Right. So two things. One is if you have doubts on any topics, we will cover them. If you don't have any doubts on them, then we will have the quiz. The quiz part for the next week in the next class rather, Thursday class, is going to be on the system, like shell programming is there and system calls. So, okay, we will just go through the C programming part. C programming, system calls related to files, directories, uh, and then processes and signals. Up to that, we will have it. System calls related to files, directories, processes, and signals. So those are the topics for Thursday quiz. And I will actually make a note of who is answering what, who are attending. So far, I have not put any effort, whether you are coming or not coming. It right? So only all of you are there. Okay, so somehow because of the call, the network got disconnected. So Thursday, that is the schedule for the time being. Quiz is on the C programming. System was related to files, directories, processes, and signals. All right. So Thursday 8:30 will be meeting. And first semester anyhow already schedule is announced. I think all of you must be busy on that particular time. But it is still time is there. Only thing is you have to apply for that particular exam by paying the fees online or whatever. I think all of you are already doing that. I know that. So Thursday 8:30 we'll have a class. Any questions then? Is my voice clear?
Yes, sir.
Hmm. So that's what it is. Start preparing and then come to the class properly. And I will naturally, like you must have your mic or whatever working there properly. You can't be silent as you have been all along. Whenever I call a particular individual, you must respond. Whatever answer that you know it doesn't matter. The minimum courtesy is to respond to the questions being asked. You can't just simply ignore, right, the calls that are actually being asked. Okay, so all right then, I will just simply stop recording. Thursday we are having the class, next class.